We have a projectile fired, the gun 45 meters above ground, emerging from the barrel of a gun, speed 250 meters per second. Projectile, and then fired at 45 meters above the ground with a speed of 250 meters per second. And we are required to find how long does the projectile remain in the air. What we will do is we need to find the equation first that satisfies the story. So it's a position y minus y initial is equals to initial speed multiplied by sine angle fired multiplied by t, and then minus a half gt squared. And then we have the downwards, so let's take it as negative so that we know the positions, and then also know that change in y is going to be y final minus y initial. And we have final height as it went down is 0, and the initial is 45, so going down was negative 45. So negative 45 meter, and negative times negative makes positive, so we have 45 meter positive. So the change in y there, so we have the horizontal, the angle for horizontal theta initial will be 0 degrees because it's horizontal, so there's no angle there. And then putting 0 there, sine 0 is 0, and 0 times t gives us 0, so that part does not exist. So we now have an equation with the first term not existing, and then we actually give in the distance, which is 45 meter positive, and that's 0 there, so giving us the equation negative half bracket, and then our g is going to be negative 9.8 meter per second squared multiplied by time, and time squared, that's what we want to calculate. So we make t our subject, so we have to solve for t, and then we know that we have 45 meter there per second squared is equals to 9.8 meter multiplied by t squared, multiplied by divide by 2, and then that gives us 45 meters multiplied by squared, and then multiplied by 2 gives us 90. So 4 times 45 is 90. Cross multiplying that, so we have 90 second squared. Remember the meter cancels out, so we have is equals to 9.8 t squared. So solving for t squared is going to be 9.8 over 90, so the root of that is the value for t. So dividing by 990 divided by 9.8, we find the root of that. Let's use our calculator. We find out that we have 90 divided by 9.8. The root of that is 3.03. So that's 3.03 seconds. Okay, so that's how long it takes in the air. Okay, and then from there we need to equation 1, we find the equation there, and then find the right equation. 2, we substitute correctly considering that some quantities are vectors. 3, we simplify further where we solve for the subject of the term, and then the fourth part is continuation of simplification, and then the fifth part solving for t. 2 values, we are positive negative, time is always positive, so we take the positive side. Horizontal distance from the firing point that strikes the ground, so horizontal distance. Now remember we have 2 parts on the equation, so t there is 3.03, so it moves both in horizontal and vertical on the same time since the 2-dimensional motion. So a change in x is going to be initial x plus, and then we have the equation there whereby you have initial velocity multiplied by cos. So now the vertical horizontal constant component is cos, so cos theta multiplied by theta. The initial theta there is 0 for horizontal direction, and we have cos 0 degrees is equals to 1, and then 1 times initial, so it's v initial there, and then the initial position that it was first, it was from initial position that's 0, No, it was not given. So change in x is going to be initial velocity multiplied by t. Exactly that. So initial velocity we are given is 250 meter per second. That's our initial velocity, and our time we just calculated is 3.03. so time speed 250, that is meter over seconds, and then multiplied by time is 3.03. so 3.03, that's our time, seconds, and then second cancels out, so we're left with meter, and then we calculate 250 multiplied by 3.03 gives us a value of 757.5. so 757.5, that's our answer in meters. So that's our horizontal displacement. So the final question is, what is the magnitude of the vertical component? Magnitude of vertical component that strikes the ground. So we need to know that as it was moving horizontal, it was also going down since it eventually reached down. So the final velocity vertical will be initial velocity vertical multiplied by sine theta, and then minus same equation minus minus g. That's gonna be minus g multiplied by t. So that we have initial velocity. Solving for that, we have sine theta is equals to 0, so that part doesn't exist. So the only thing that we have is the vertical component will be negative multiplied by negative 9.8 meter per second. So that's what we have, and then the time is 3.03, so per second squared. Okay, and then we have a positive there, so that's 9.8 multiplied by 3.03, giving us 29.7 meter, so per second. So meter per second. That's our final answer. Thank you so much for watching, and this is your tutor 5D. This is your 5D tutor Black Adam. If you, by 5D I mean that I do a minimum of 5 subjects, but specializing on maths and physics, and this means that you can post in any problem that you have. You can go through the channel and see if there are things that you might love. Thank you for watching, and don't forget to follow or subscribe. This is our Black Adam 5D tutor. Don't forget to follow or subscribe.